Right. Hello everyone, Mr. Barden here. I'm coming at you with another Arduino video. I've got the components set up right here. I'm going to talk a bit about what I'm going to be doing, but we're going to, compared to the previous videos, actually be implementing some Arduino code to have the board run. This will effectively have the same end result as the last video, which was pushing the button to make the LED turn on. However, the way I'm doing it now has a much more wide potential for applications. So in the last video, we were just using the button to complete the basic circuit that was powering the LED. In this one, the button itself will be its own circuit that the Arduino will then respond to and we can use to power the LED. So I've got this board set up. This is a little tool I make for my students. And it's essentially just got the button circuit and the LED circuit here already wired in, ready to go. I am just going to power it on right now. You know, this LED really, we do not like the, my camera doesn't like the blue on this particular one. Although we've got all kinds of purples and stuff going on as I move it around. But anyway, so I'm going to leave it unpowered for now, just so that's not very distracting. But that's basically all that's happening here. It's just got a yes, the power is on light, a button with its circuit, and an LED with its circuitry. Basically, all that's happening in these circuits, and I'll walk you through it here. Okay, that should be nice and in focus. Is it's going to get power, and the power is going to everything in parallel, so we don't have to have anything running. They can all run independently. Ground is the bottom right here, so again, when we connect ground, that pops on, and everything else can run. I am aware that I am using a yellow cable for the ground right now. I'm saying this for all of these videos just in case you watch them out of order. I have ordered more jumper cables. I don't have any more black ones of this length for the ground. So it's going to temporarily be yellow. So again, for the LED, it's pretty straightforward. It's getting power from there, and then it's going through the resistor right here, which is 220 ohms, and then to ground. Exact same thing as this LED, except instead of getting the source from the power, it's coming in from a separate input on these little pin headers right there. The button is a little bit different. We have a few things going on. So we're getting the power coming in, and then it's going through the button, and it's going in one way through a 10K ohm, so 10,000 ohm resistor here to ground. That's happening there, but we're also dividing that and picking it up through another pin header over here. And basically what this is doing is this will let us just, say, oh, hey, there's electricity flowing through this or not. And by having that resistor there, we can kind of avoid some short circuiting. On the back, again, it's not the prettiest bit of soldering ever, but you can kind of see where some of those are connected and all things branch off. I do not consider myself a soldering master by any means, but I can get it done. These are uninsulated, so for many of my students use this, that's why I have them on the legs, so you can't very easily touch them. Not that this is enough electricity to hurt anyone, but just know that if I was to actually make a commercial version of this and sell it or use it in any kind of way, I would make it much prettier and safer. But let's just get into it. So I've got the Arduino code now that we've kind of broken down everything, and this is just the default code. We have it all right here. So we can type in our code editor, and I'm going to say int. We're making a variable here with int, and it's going to specifically be an integer value. It's also going to be a const value, so a constant meaning this will not change. These are a few things that Arduino you have to do over just pure JavaScript like we've been doing in these classes. Um, in the sense of you have to say what kind of variable it is so it can be used for different things. So an integer is, whole numbers. A constant value doesn't change when the code runs. This is different than, say, a floating point, which is a decimal, or a character, which is like a string. So it depends on what you're going to be using it for. But we'll say LED pin. It's going to be, let's use pin number 7. Why not? On the Arduino board. So we've got that there, and then we've got, we'll say int const button pin, and we will have that on pin number 4. I'm just kind of arbitrarily picking these at the moment. I do also want to stress you do have to have the semicolons at the end of your lines here, otherwise this won't work. I'm now looking at my screen, how I have this set up, and this text does look a little small. So if you watch this on your phone, you may want to consider watching this on a bigger screen so you can zoom in. I may adjust some of the balances of this moving forward. We'll see. Again, this is a learning process for me trying to keep everything on the screen at once. But we've decided what pins to use, and these are just the numbers that are on the Arduino right here. We can kind of see them along the side. I'll talk about what more of these symbols mean when we get to them. But these are what we're going to connect everything to. So let's look in here. So let's go to setup now. So digital pins can either be an input or an output. They can send data to stuff, or they can receive it. So we have to say pin mode, and we have to tell it what to do. So the LED pin, because we're going to be outputting voltage to the LED, this will be output. And then pin mode, the button pin, we will want to see if we are receiving electricity. So this will be an input right there. So that's the first part, and we're just saying, hey, what is all the stuff. So what are the pins doing? So we can go into our loop, and this is where we're going to be checking to see if the button is receiving the voltages on that pin. So we can use a conditional for this. We can say if. We can say if. We got a few things here. We need to check to see if there is voltage on that pin. So it might be a good idea to make a make another variable to control that. So we can say this could probably be an integer, but I'm going to say float. And we'll see if that gives us a problem in a second. Float button voltage, or button pressed. We'll have that right there. We can just give it a default value of 0 if we want, but we can check every loop. That's what we're going to do right here. We'll say digital read. So this is a function that takes an input pin that is digital. We set that up here, and it says, it just reads what that value is. So we're going to read the button pin right there, and I want to store this inside button pressed. I'm going to assign that right there. So if button pressed, if there's a value there, then we will say digital write, and we're going to write the LED pin to high. Else, we can say digital write. We will say LED pin to low. So what this will do is we will check every frame that this is running. What is the current state of this pin, and we're going to store that in a variable. Digital pins like this can only go between high and low, on and off, 1 and 0, that kind of thing. So if there is a value for that, it's not 0, we're going to write this LED pin to high. We're going to turn on the LED right here. Otherwise, we're going to set it to low. We're going to test this. I haven't really tested it yet, but let's just upload. Oh, I have to save it first. Do I? Okay, there it is. We've uploaded. So let's see. Let me just kind of arrange this here. So it's on. So now the second one here happens to be connected to the LED, so that's going to be there. The LED pin is number 7. And then the one next to that should be the button pin. And again, we're going to connect that to pin number 4, 0, 1, 2, 3, 4 on the Arduino. So now this is the moment of truth. Again, I didn't test this before I started streaming, which I probably should have. But if I click this, yeah, nothing happens. Let me just double check that I've got all of these on the right holes. I can just test this by doing that. Okay, yeah, that is the right one for the LED. So LED pin goes into, I think I may have had that on the wrong one on the board. And then 2, 4, 1, 2, 0, 1, 2, 3, 4, like so. And there we go. Okay. So again, I just I had these plugged into the wrong pins on the board here. We have it there. So this button is going to run, and let me just adjust the focus a bit. There we are. So this button is going to run its circuit. We're going to see, is it getting voltage on this pin? And if it is, the Arduino is then going to manually turn on this white LED over here. So we have run into some issues. Sometimes it may get a little residual voltage in there. Sometimes it may not go, and that's more towards the build quality than anything else. If you were to do this on a breadboard, I think you might have a better response. But we can see that as I click this, the light turns on. This may not be as immediate of a response if you were really, really, really counting, because we are limited by the speed of the Arduino. These aren't the fastest boards in the world, but the benefits of it are you don't have to use a button and an LED. You can use any digital input device in order to set this up. I don't have a whole lot with me right now. A lot of my sensors are analog, which we'll get to in a later video, but basically what we can do is maybe you don't want to use a button. Maybe you want to use a motion sensor, or maybe there we go, or some other digital sensor that can respond to something. Maybe air pressure, airflow. Again, we had the movement as an idea. Something else like that you could use to power a light like this, or any other circuit. So again, the possibilities are really only limited by what you want to do and the parts that you have access to. Again, you could run effectively this same code and just change out the components. Stop that. Ground properly. Again, it's not the best board, but it's just a quick thrown together teaching aid. But you can swap it out for whatever you really want, which is very, very useful. And it could be way more complex than this, or this is just about it. When I write Arduino code, I try to make it as simple as possible. Let me just kind of move this over here so you can see it. That sketch, this 1, 2, 3, 4, 5, 6, 7, 8, I don't know, less than 20 lines of code take up 3% of the memory of this chip. These boards do not have a lot of memory, so I try to make the code as simple and small as possible. So it is electricity coming in, then do a thing. It's that simple. Transmit a small value. It's pretty straightforward. So I'm going to leave it right there, but I think that pretty much gets everything that I was wanting to get across. You can use the digital write and digital read functions in order to either set an output pin to be a value. We can use it, again, we're using that to turn this LED on and off. They only have high and low values, so that's what you have to work with. You can't set it to anything other than that for the most part. We're going to talk about analog inputs, and then we'll come back to the digital and work with something called pulse width modulation in order to kind of get around that limitation of the digital aspects. So again, just to go through the code one more little bit. Again, you have to set your variables. You have to specify what kind of variable it is. That's different than JavaScript. So this didn't necessarily have to be a float, but I did it anyways just so we could see a few more options. You have to set whatever pins you're using digitally on your Arduino to either be an input or an output. Depends on whether it's receiving electricity from a circuit or it's sending it out to the circuit. That's what determines that. And then we can use the digital read function in order to get in any of that that voltage, and we can store it somewhere. We can have other things respond to it. We can send those values to other places. It's all pretty useful. All right, so I think that's gonna be it for me. I'm gonna end it right here before I just keep on rambling and run out of camera battery and everything else. If you enjoyed the video, if you learned something, feel free to give it a like, maybe subscribe if you would like to learn more. It definitely helps out, YouTube stuff, blah, 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 blah. I'm not going to go into all of that. If you have any questions or concerns, maybe you make something really cool and want to show it off, or you're like, I didn't quite understand this, or I think that was completely wrong. Leave those down in the comments. I love, hearing from all that, seeing what people can do, ways to make my videos and materials better is always very helpful. So that's going to be it for me.